I'm Nelson Arapé. I'm from Venezuela, but living and working for Spotify since 5 years ago. I'm in the data infrastructure department. We call it Tribes for some reason. And I am in the team doing the event delivery. This will be our agenda. We will give a brief introduction of what is the event delivery. We will go through all our 3 generations, but I will not focus most on architecture. I will want to focus more on learnings, because this is the things that you can maybe apply yourself. Okay, I would like to see hands if you know what Spotify is. Okay, basically all of you. We are a music streaming service. I think here you have something called Yandex Music, so it will be similar to that. You have in your device, your mobile or your desktop, access to millions of songs from artists all over the world. As I said, we are in mobile, desktop, wearables, screens, speakers. Now, let me talk about what is event delivery. First, when you use your application, let's say you are interacting with that, we show you several parts of the application. And it's our interest to know how you reach to that point, what part of the interface you use to reach to that point. For example, when you play the song, we want to know if because you came through search or because it was a playlist that we promote, or you are just listening songs and we need to know what's happening on your application. We call these events. Events is a piece of data with some information in it. We have 300 different types of events, more or less, right now. And some are important, like, you just listen to a song. Some others are less important, and different to other event delivery system called, maybe also you will hear it by data ingestion, is that we are not allowed to drop data because we use, for example, these songs to be able to compute how much we need to pay to labels, for example. So how this works? All the events are generated on the application, they are sent to the Spotify backend, and then we use these for, as I said, computing how much we need to pay and to whom. We also create data analysis and to understand what is the behavior of the application, or what is the behavior of the market. For example, when we jump into a country, we want to know in real time how we are doing. We also are part now of the top 100 Billboard chart. So we need to produce these reports, so the music industry we use to decide, okay, who is number 1, who is number 2. And also we use this data to fuel or drive features inside the application. For example, this is one feature, it's very popular, it's called Discovery Weekly. Here we create a playlist for you. So we, based on your history, your preference, we think that these songs could be interesting for you. And we call it Discovery Weekly because maybe you haven't heard those songs. So this is a great way to people to find out new music. You would say, yes, this is a copy tool. Basically, you are copying data from the devices to the backend. What is the big deal? The big deal is the scale that we are talking about. We are transferring 250 billions of events per day. If I translate it to events per second, it will be like 4.5 millions of events per second at peak times. We also need to deliver this data without losing any, or lose as little as possible. We need to have some margins. And we also need to deliver on time. So this is the challenge of our event delivery system. If all this architecture that we'll present now have this super very high level view. We still have the devices. We have a magic box now we call event delivery, and then we have at the end a distributed storage. This is where the rest of downstream consumers will pick the data from. Okay, I talked about the 3 generations, and these are. Our first generation, when we were small and naive, was based on FTP. We were copying files. Then, when this didn't work anymore, we moved to a Kafka solution. We used Kafka 0.7. It was current at the time. And then our current solution is based on Google Cloud PubSub. Google Cloud PubSub is also a PubSub system, just that it is from Google and is managed in the cloud. So let's go with the first architecture. Before jumping to architecture, I want to picture how was Spotify at the time, because this is important to understand that, how the context of how our event delivery had to manage. So Spotify was just our beta. We were available in 5 markets. We have thousands of users. It was like the free tier was invitation only, for example. And our primary use case was to create the report for the labels. So how we did it? We have our devices, and we have the Spotify backend. We send events, and we configure syslog to write those files, those events to files. And also we configure syslog to create a new file per hour. So we will have the file for hour 10 and the file for hour 11, 12, and so on. So we just had a cron task that took these files and sent it to some machines we are calling now here collectors. So these machines were receiving these files from several service machines. And from here, we copy this data to HDFS. Why not doing it from the service? Because we wanted to have like certain control of which machines are allowed to have the access to Hadoop. And also, we focus all the configuration related to that only on those collectors. At the end, we have a MapReduce job that took these logs, filter invalid data. For example, here in this log, we also have events, but we have a stack trace or debug messages. So not all the data is interesting for us. So we have this filtering part. We parse these events that are written in text. We parse it to Avro, and we split it based on the event type. So we have those go for one event in one directory, and the goes for other event in this other directory. So what will be the plus side of this architecture? Something that it was good about this is the event delivery was never a critical system. So even if we have a problem with the event delivery, we wouldn't stop the music from playing on the device. So that's very good. The less system you have in that condition, the better. We also, we achieve this because we have very good decoupling. We have the client send the data to the service storing in files, we copy those files, and then we have processing at the end. So this decoupling allows you to evolve your system, not all at once. And I will say that, yeah, it was simple. Basically copying files. On the downside, we have some silent failures. This was before my time, so I feel for this talk like an archaeologist trying to dig up all documents and all presentations. But what the team at the time reported is there was some silent failures that it was painful to operate because, let me go back. It was painful to detect. We have a system that realized that, yes, on the post-processing side, we have all the data that we need. But if for some reason we have a missing file, then it was a manual copy from the service host to copy this file that for some reason didn't transfer. Do you know service level agreements and objectives? This is like a promise that we as a service provider do to our downstream users. In our event deliveries will be like this. We guarantee that 99.999% of the data will be available within this amount of time, the 90% of the time, or something like that. That will be a SLO statement. SLA will be like, okay, what will be the penalties if you don't achieve that? But because we are inside the same company, we don't have that part. So the problem with this is that we're a young company and we didn't have any SLOs. Yeah, the data was there most of the time, but sometimes we have somebody calling us, hey, I don't see my data, and then we start figuring out what's happening. Yeah, yes, we realized that, yes, it was blocked because of this or because of that. But I would say the most critical part was that our collectors were a single point of failure. We transfer this data to this machine. We are copying files. We are not replicating that copy. We have only in that computer. And then we send it back to HDFS. So from time to time, we have failures in these collectors, and then it was a manual process to understand what data is missing, and we have to go to the service to find those files and then copy it in a manual way. Have you heard you need to have cattle instead of pets? Here was the other way around. We have our collectors were our pets. We need to take care of them. It's not that now you have several machines. If one is not behaving, you just kill it. Here we have data on those, and we need to care about that data. This is our first learning that I want to share. This system, copying files, served us for several years when we were young and we were small. So not because there is a fancy technology, you have to use it. Go for what is simple. And of course, it will work until it doesn't. There was a point in time where, yeah, this simple solution was not enough. Okay, we have our second generation based on Kafka 0.7. This was how Spotify was at the time. Now we have grown from 5 to 55 markets. We have 24 million users using our application. Those users were producing 15 billion of events, and we still need to create our monthly reporting, but now we want more. We want to create analysis. We want to understand how we are performing in those 55 markets in real time. And the solution of copying file was not good enough anymore. So how we did it? We decided to keep the same interface on both ends. So we have the files on the service, but then we have an agent now that is telling the logs, send it to a Kafka broker, And of course, we have a consumer that writes to HDFS. Maybe we jump into Kafka too soon, because this version 0.7 didn't have replication. So basically, we had a new single pole of failure. What we did, we created this. We took, once the consumer wrote the data in HDFS, we sent a message, application level ACK, acknowledgement, back to the brokers, and then read it back in the consumer. So, in the producer, sorry. So our producer will know that, yeah, this data was safely saved in HDFS, and if we have a timeout and the ACK takes so much time to arrive, we will send it again. So we have an application level end-to-end ACK loop. Finally, we have our same post-processing part with the filtering, parsing, and splitting. In reality, it was more complex than that, because we need the Kafka broker, the Kafka cluster, the zookeeper that controls the cluster. We had 4 data centers that we need to transfer data across those data centers. We also need like zone checks, and so it was something more like that. So, okay, let's go with the plus side of this architecture. We supported now real time. We're using Kafka, of course. Our solution to real-time understanding of the new market openings was very good for the business. Now we are able to have more we have a more scalable system, because before we need to have enough collector to hold the data of the whole company a few hours in this. Now with the brokers, we are just streaming data, and yes, it will depend on how fast we are writing, but you get the point. We don't need the whole collector have all the data for the whole company. On the plus side, this is a big one. It was super complicated to operate. This ACK loop was a pain, real pain. Why? Because suddenly we have a drop in the throughput. We couldn't transfer data as fast as we could some hours ago. What happened? We don't know. We don't know why, because it's a loop. The producer is waiting for ACK to arrive to send data. If the ACK, he does receive ACK, we have like a TCP window. So we have a window that we allow to be on the fly. So if we fill up this buffer and ACK are still not coming, we are waiting, we are blocked. And find the root cause of that, why the ACKs are not coming, was difficult. It could be in any part of this loop. It could be like how our engineer used to call it, like internet weather. It was like, for some reason, the throughput of internet, dropped. So it was a lot of manual work. Maybe we need to tweak we have increasing load, we need to tweak this buffer or tweak over here. And the worst is that if the timeouts arrive, the producer is sending more data. So now we are not just blocked, we are just recirculating data all over again. Yeah, these end-to-end acts hides where this bottleneck were. And also we design our system to be 100 guarantee of deliveries, meaning that if we have like the minimum idea that we could have received more data, but we are not receiving more data, we will block. So these sometimes also require our manual intervention. This, we have this complicated system. But for our downstream users, I mean, the data engineers is what I'm talking about, they didn't see that much besides the new real-time use case. Those that were consuming batch, basically for them, there was not much difference. And there was not much difference for one reason. Of course, we didn't improve SLOs, but why we didn't improve SLOs? Because we have basically two teams working on this. We have the teams that copy the files, and we have the team that post-processes these files and make it available to the data engineers. So there was never one team holding the whole problem. If this is late, they point to us, and we say we transfer the data, we point to them. And the interface between our two teams was not clear. When it's safe for the post-processing to run was not clear. And this realization was what triggered our architect. We focus on how to copy the files instead of focusing how to deliver events. This is our learning number 2. If you may focus on the wrong issue if you don't own the whole problem. So after this, we made some changes. Now the event delivery team also owns the post-processing part. And actually now we own the whole problem. And soon after, we actually start with improvements in our service level objectives. Actually, we create one. We say we want all the data be available after midnight, these many hours. By the time our more demanding use case, now we are creating daily reports, and also we are creating billboard charts. Those need to be delivered weekly. Before it was, the monthly report was only at the end of the month, so we have some slack to, if we have like an incident, we recover and we are good at the end of the month, nothing major happened really. But now we have more demands on our platforms. Yeah, so how we did this? Now we have implemented end-to-end monitoring. We wrote some slow components. We realized that this post-processing part at the end was taking too much time. We rewrote that code. It was Python streaming, and now we were using Java Crunch. And we simplified this interface. Now this component talks more easily with the part that copies the files. When to trigger this processing part goes more fluidly, because now we are the same team. We understand we wear both hats now. So we have an idea what to do. By the time we were operating this, now Kafka was 0.8 and have replication. So you say, yes, let's get rid of this ACK loop. But also, we realized that part of the problem is that by copying the whole file, we have now, at the end, all the events intertwined in one big chunk. So this processing part was taking so long because it have a lot to do. It's operate on a lot in the data that is the input to that process is really big. So we thought that if we move part of the solution at the beginning, let me go a little bit faster. What we wanted is to solve that problem. We have this MapReduce job doing a lot of work, and we wanted to reduce that load by moving some of that processing part to the beginning of the event delivery system. So yes, we are all set. We have a new idea, and by the time Spotify made a partnership with Google, so we are now have like we could use new tools and to build our event delivery system and say, wow, this is really cool. But we have the old system still running. The name of this talk is the event smooth flow, so we cannot just, oh no, let's pause this, we are going to build our new one. So we decide to, let's create a new one. What could be wrong? What could be wrong? We call this the summer of incidents. Everything was triggered based on a problem with our Hadoop service that triggered a down cascade of incidents in our event delivery. We were not transferring data fast enough. We took people for the rest of the company to work with us, try to solve this issue, figure out where were the bottlenecks again, and then that help, we have our help, but that help was not effective because our monitoring tool was not very good. We were doing too much. So out of that, I want to point out two learnings from that. One is that you are not able to jump in a new system without making sure that your old one is stable and reliable. I mean, you won't have time to work on the new one, meanwhile you are firefighting your old one. And the fourth one is that if your team is overloaded, maybe you can identify a few things, like our monitoring. We decided to give away the monitoring responsibility to a new team. They took this concept and created it as a platform and available for the whole company. So this was a cross-cutting concern that then we were able to give away to get some help, to get some air. Now, to the third generation. Spotify is bigger, more markets, more users, more events, and more use cases. We're starting to use data for driving features. How we did it? We still keep the files at the beginning. We have our agent that pushes the data to a service. This service now is doing part of what the post-processing part was doing, is doing the filtering right away, so we don't need to move that data. It's also doing the parsing. But not only that, it's also doing splitting. So we are producing, now instead of having one topic for all the logs for this service, now we are producing several topics where we are pushing the data per event type. At the end, we decided to use Google Cloud PubSub. Two reasons for that. One is a managed infrastructure. So we didn't have to care about brokers and zookeepers and how many partitions, how big are the disks. That is Google problem. And the other one is that it's a global system. So we can push data in America and consume it from Europe without having to figure out how to configure the mirror maker of Kafka and any of that. And now, because we have per topic, per data event, so we have our consumer pipeline. Now we have a dedicated per event. So we have our consumers write events, and we have MapReduce job to process those events. Plus side, we have a simplified system. Killing that ACLOG help a lot. Also, using managed infrastructure help a lot. Of course, it's easier to operate. We are able to increase the load, not only because we're using Google infrastructure, but because also our post-processing at the end now is just the duplication. The filtering and splitting, all that happened at the beginning. And because we managed to work in a higher level abstraction instead of moving bits, we are now moving events. Now we track ownership, we keep the events isolated. So if we have suddenly bursts on a low topic event, on a low priority event that won't impact the high priority event. On the downside, this is an expression, I don't know if that translates good to Russian, is that we have a lot of small incidents. We have 300 events, and now those could alert independently. So it was like a cascade of a small incident instead of one big one. We were using beta software at the time, also Google part and our part. But this was the real issue here. All the events were treated equally. So we have the really important ones that drive the business, how many we have to pay. We have that we have to provide 24/7 support, but we're doing the same with random any other event in our system. And I would say we still rely on syslog. We still have data on the service, and this is still a pain because now we have more services, and that part of the services make it a little bit less a pet, not as a catalog we would want. This is my final learning today. You need to improve your life to focus on what matters. How we deal with this is that we create 3 groups of events. Those that are really important that have 24/7. The majority goes to normal, where we have from 9 to 9 a.m. to 9 p.m. support. And there's another lot that is low priority that they could wait to the next business day. So by segregating the events by priority and making our alerts accordingly, we will be able to have a better quality of life because now we focus on really what matters. And the journey continues. We are not done with the event delivery. We still need to get rid of the syslog files. So we are still evolving our system. So let's do a recap. Keep it simple. It can get you a long way. Own the whole problem. So you avoid focusing on the wrong thing. You need to stabilize your system before moving to the next one. If you are overloaded, try to find a cross-cutting concern and create new teams based on that, so your team could have more room to do stuff. And focus on what matters. So create priorities and delegate to next business day or something like that, things could wait. Thank you. This is a question that, I don't know, if I tell you, I will have to kill you or something like that. I don't really know. We are deep in the software side, the market side is other people. There are some comments, but I'm not allowed to speak about it. Which layer of data your team is responsible for? Final reports? No, we are not. We are a platform team, so we make the data available. We say we have some counters to say, okay, this data have like this many events. We have do some profiling to know like general shape of the data, but we don't create these reports. I don't know if you are familiar with DevOps. In Spotify, we do data ops. So we have data engineers with teams. And if they need to do reports, they will have a data engineer to do the reports. And usually they talk to us like how to, or we work for them, for the data engineers in running in the squads. What's the vision on bird or lock-in? That's a really difficult question. Yes, we are with Google. We have, actually, I don't know if I am allowed to talk about this, so I will rather shut up. Maybe with the beers I could tell you something else, but I'm not sure. The thing is that we know that this is a risk, and we try to mitigate it some ways. I don't think I am allowed to say more than that. How difficult is post-processing part? Data amount of time? As I said, we are transferring 250 billions of events. And each event is like 500 bytes. You do the math. And not only that, after we produce all the data, then we have to pseudo-anonymize it, because now we have GDPR, and we have to encrypt some fields with the user-derived key. So if the user decides to leave Spotify, we just throw away the key. We don't go back and modify the data. And not only that, our user generates like 3 or 4 times the amount of data that we send. So it's not only the data we transfer, it's the data that is derived based on that. So yeah, it's a lot, but I don't have the numbers for you. What about fraud detection? Yes, our event delivery, the part that runs on the devices, is created with some security concern to try to avoid people cheating and sending fake data. And also we have a team focused on identifying fraud on the consumer side. So we have measurement here, fraud detection and prevention on the other side. We do code reviews. Yeah. What do you feel? Why do we feedback to the producer? I guess this is the second architecture. Because we couldn't trust our Kafka brokers. Remember, this was 0.7. They didn't have replication at the time. Replication came first in 0.8. This is why I say my comment that maybe we jumped into Kafka too soon. The 0.7 didn't have replication. So we couldn't trust that once we copy data to the broker, that data will be successfully saved in HDFS. That's why we need to create this ACK loop to be able to know for sure that we transfer that data safely. How you guarantee the event delivery? How we exactly want. I mean, the whole system is at least one. We run the duplication at the end. On top of that, for ITGC reasons, there is some compliance regulation. We also need to prove that we are transferring all the data. So we, on the service side, we are counting. I didn't put that on the slides to make it simpler, but we are counting how many events are we sending per type, and we do the same to the other end. And so for those events that really require it, we match these together and say, yes, this was produced, this was what we received, and we do like a counting system to actually prove that we are transferring all the data. This is how we prove that. How we guarantee there is at least one, as I said before, we have resends and we do the duplication at the end. What's the problem with syslog? Yes, the problem with syslog is that for example, right now we are blocking the deployment of Kubernetes in a lot of our services because you will want to auto-scale your host based on load. So if you are, during the day, you want to deploy more service, and during the night, you want to reduce the amount of service. So if we are spawning new machines and then destroy it, we we will need to insert something special to understand that, no, you cannot destroy this machine yet because we have data in syslog that we still need to send. Our system, in theory, should be just a few seconds behind of real-time production, but if something bad happens, we have an incident of some kind, and the machine decides to downscale, we will lose data. So that's the problem. We don't want to have important data in syslog. We want to ingest this data directly without using service machines. We want to treat those machines as a cattle instead of a pets. There is a question over there? Maybe you can say loud.
Unfortunately, we don't have more time for question, but you could ask everything you want in the Ask corner. And I'd like you to present a small gift from organizers.
Thank you.
And now let's close one more time to